Hi there, Mr. Sutton here, bringing you this IM3 Honors 4-3 lesson on the quadratic formula. In this one, we're solving quadratic equations using this formula, and as a real-life application, we'll figure out how long it takes a projectile to fall to the ground. For your warm-up, now that you've gotten so good at completing the square, see if you can do it for this equation here with a, b, and c as constants. So pause the video and see how far you can get. All right, let's see how you did. So we'll clear out the constant to start us off here, this c value. We'll subtract that to the other side. And then we don't like this coefficient of x squared, so we'll divide everything by a. So x squared plus b over ax equals negative c over a. Now for the completing the square step of all this, we have to take half of this x term and square that and add it to both sides. So this is going to be b over 2a, because you can double the denominator, and we'll square that and add that to both sides. So for the left side here, we can now factor this into a squared binomial. Using our little trick from before, we're just going to take the two things that are being squared and put them in a squared parentheses with the sign of this middle term. So x plus b over 2a, quantity squared. And on the right side, we'll have negative c over a plus b squared over 4a squared. Now we can combine the stuff on the right side. So we need a common denominator to do this. I already have an a in this denominator, but I need another a and a 4 to get it to be the same as this denominator. So I'll multiply this first term by 4a over 4a. That'll give me negative 4ac over 4a squared. Now I'm going to add these two together. I'm just going to write this with the positive term first, so b squared minus 4ac all over 4a squared. Now we're going to square root both sides so we can start getting to that x in there. So that'll have x plus b over 2a on the left equals plus or minus, I have to square root the numerator and denominator. So we can't really do much with the b squared minus 4ac. We'll just call that square root of b squared minus 4ac. But the 4a squared we can square root. That's going to be 2a. And now I'm just going to subtract b over 2a to get it to the other side. Since I already have a common denominator of 2a, I can just put all of that in one big numerator. So when the dust settles, I've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is what we call the quadratic formula. So that probably seemed like a whole lot of work with all these letters floating around, but what have we accomplished here? We have created a formula that does all the steps of completing the square in one nice, neat little package here. Now you might wonder if I can just use this formula to solve any quadratic equation now. Do I really need completing the square or factoring? Well, factoring is often faster than using this, and it doesn't require you to memorize some formula. Completing the square, you no longer really need to use completing the square to solve quadratic equations unless a test question asks you to do it with completing the square, which it might. However, you do need the process of completing the square for changing equations into forms that are easier to graph. You'll see this when you do circles, ellipses, hyperbolas, and parabolas. It is still nice to be able to complete the square to change forms. But for solving quadratics, this formula is actually pretty nice. So, as you can see, the quadratic formula is a little bit tricky to memorize. It's going to take a lot of repetitions. It also can be a little bit tricky to use. Take this example now. We're going to walk through this one together. Now, you can only use the quadratic formula if your equation is in standard quadratic form. That's ax squared plus bx plus c form. So if it's not already in standard form, if you don't have 0 on one side, if you're not going in decreasing order of exponents on the other side, put it in that form, and then write out your a, b, and c values. So here, this 8x is going to have to come over to the left side between the x squared and the 1, and that'll be a negative 8x. And then I'm going to write out what a, b, and c are. A, again, is your quadratic coefficient. B is the linear coefficient, so negative 8. And then c is just your constant, in this case is 1. So here's our quadratic formula again. And now I'm going to plug in whatever I can for a, b, and c. So first thing, I've got a negative out here in front of the b. A lot of people forget that, so don't you forget it. So this will be negative 8
Inside I've got negative 8 squared. And then we've got 4 times 11 times the c value of 1, all over 2 times the a value of 11. All right, let's walk through this and simplify it now. We could just plug it in the calculator, but they're probably going to want in simplest radical form, so we do have to crunch the numbers and simplify it if we can. So we've got negative 8, which is positive 8. Negative 8 squared is 64. Then we have negative 44 if we multiply all that out, all over 22. So that's 8 plus or minus the square root of 20. 20 we can split up into 4 and 5. Square root of 4 is 2. So we've got 8 plus or minus 2 radical 5 over 22. Now we can reduce this a little bit. The rule for reducing things in this crazy form is if this number, this coefficient, and the denominator are all divisible by the same number, you can reduce all of them by that same number. If any of them are not divisible by the magic number you want to reduce it by, then you can't do it. So these are all divisible by 2, so we can rewrite this as 4 plus or minus just 1 square root of 5. We don't even need the 1 there, actually, all over 11. So that'll be our final answer. Let's do another example. For this one, we'll do a real-life problem. English archers on a hill fire some arrows at some Scottish rebels 120 feet below. So here's our Scottish rebels. Freedom! So here's our arrows. Arrows meet Scottish rebels. Whew. Oh, no! All right. So the arrow's height is given by this formula. H equals Vt minus 16t squared, where V is how fast the arrow's going. And T is your time. We want to know how long the Scots have to find cover from this rain of arrows that's been fired at 56 feet per second. So we've kind of frozen time here. We're actually going to go back in time before we even got in this situation so they can calculate in advance how long they're going to have to lift those shields. And why don't they just keep their shields up in the beginning? Well, they want to lure the English archers into firing and wasting their arrows. So if you put your shields up right away, obviously that's going to give away the game and they're not going to fire their arrows at you. So we've got our height formula. Our target height is 120 feet below, so that'll be negative 120 feet. And our velocity, our V, that's going to be this 56 feet per second. So plugging all of that in, we have this nice little equation here. We still don't know the time. That's what we're trying to figure out, how long before the arrows land down here. And we're going to figure that out on the next slide. So here's our equation to figure out how long it's going to take those arrows to land. We need to rearrange things. So we've got negative 16t squared. We've got a 56t that will have to move to the right side there. And just to make our lives easier, we're going to move the 120 over here, so we're moving less things around. So we'll have a plus 120. All that equals 0. You also could have subtracted the 56t and added the 16t squared over here. Just a little less movement this way. All right, now before you go ahead and plug this in the quadratic formula, is there something we could do to make our lives a little easier? I mean, we can plug these big nasty numbers in the formula, and it'll eventually work. But we're going to be dealing with some very large numbers if we're squaring things and multiplying things. So what we can do before using the quadratic formula, you're still allowed to divide by common factors in order to make this a little bit smaller. These are all divisible, for example, by negative 8. If I divide everything here by negative 8, I've got 2t squared minus 7t minus 15 equals 0. We didn't have to do this, but I think you'll agree these numbers are a little bit nicer to plug in than what we started with up here. All right, pause the video and go ahead and use the quadratic formula on this. Get as far as you can. So here was our quadratic formula again. A value of 2, B of negative 7, C value of negative 15. Again, note that the sign stays with the number. And now plugging all that in, we've got negative 7 plus or minus negative 7 squared minus 4 times 2 times negative 15, all of that over 2 times 2. Crunching our numbers, we've got 7 on the outside, plus or minus square root of 49, plus 120 all over 4. 49 plus 120 adds up to 169. We can square root 169. That's going to be 13. Now we have to be a little bit careful here. If you're able to square root this number, we weren't able to fully square root the last example. We made it like, 2 radical 5. That radical 5 was still left in there. If you are able to completely square root this number, then you're actually going to have to take everything a step further and reduce the whole fraction. And to do this, you have to realize you've got 2 different answers. We've got 7 plus 13 all over 4. And we've also got 7 minus 13 all over 4. We'll do this branch first, though. So 7 plus 13 is 20. Divided by 4, that's going to give us 5. And since this was a real-life problem, that's 5 seconds. So that's one answer as to how long the Scots have to lift those shields. Not a whole lot of time. Next, we've got 7 minus 13 over 4. So that's going to be negative 6 over 4, which is negative 3 over 2, or negative 1.5. This answer doesn't make as much sense. It's really difficult to talk about negative time. So we're going to stick with this answer, but mathematically these answers are both correct. For your wrap-up, real quick write out the quadratic formula. Go! All right, did you get it? Here it is again. Now the reason I'm having you do this is because some people are going to complain about having to memorize this. You do need to memorize this. This is not typically given to you on any kind of standardized test. However, just keep in mind it could be worse. There's also a formula for solving any cubic equation, anything with x cubed as the highest exponent. And here it is. No need to write this down. I already put it on your guided notes anyway, just for fun. So your cubic formula, if you have ax cubed plus bx squared plus cx plus d, it's going to have 3 answers. Quadratic formula has 2 answers. Cubic formula has 3 answers because we have a power of 3. So here's your first answer. We're going to have x equals the cube root of all this happiness plus the cube root of this other happiness, all of that minus b over 3a. Have fun plugging that in. That was just your first answer. Here's your second answer. Oh my, that's even worse. Here's your third answer. All right, so I think hopefully we're counting our blessings and being happy that we just need to memorize the quadratic formula. Until next time, this is Mr. Sutton, signing off.